Hello and welcome to our lesson on radicals, rational and irrational algebraic terms. First, let's talk some definitions. A rational term is a number and a variable combination that can be written as a ratio or a fraction. So, if we look at 2x, 2x can be written as a fraction by simply putting it over the number 1. 4x squared can also be written as a fraction by putting it over the number 1. How can 9y squared, the square root of that, be written as a fraction? If you take the square root of 9, that would be 3. And if you take the square root of y squared, that would be y. And you can put that all over the number 1. So you can write that as a fraction. And then 1.6, z to the 7th. 1.6 is actually 1 6/10. So you can write 1 6/10, z to the 7th. Because you can write these as fractions, these would be considered rational terms. But what if the number's not rational? Then it would be irrational. An irrational term is a term that cannot be written as a ratio or fraction. We're going to take a look at why these would be considered irrational numbers. A repeating decimal, the 1.6, and that line above it says the 1.6 66666 keeps going on forever. So a repeating decimal never has an end to it, so it can never be written as a fraction. If you don't know what the last number is in the number, there's no way you can put it over anything. Radical 2 is irrational because if you punch it into your calculator, you're going to end up with a non-terminating decimal. Again, if it's a number that goes on forever, we don't know where to stop and put something underneath it. And 3 pi. Pi is one of the most famous irrational numbers because it definitely never, ever, ever ends. So you can't put it as a fraction either. Now, question is, are these rational or irrational terms? If you plug in 3 and take the square root into your calculator, it will not end. This would be irrational. Because if you have a non-terminating decimal, a decimal that never ends, it's automatically an irrational number. Here we go again. We've got a 3 under a radical sign. That's never going to end, so we can't write that. That again would be irrational. And then, if we look here, we have some pretty special numbers. The square root of 4, the square root of 16, aren't those perfect squares? So actually you would have 2 over 4, and you can take the square root of y to the 16th. Remember, you're just looking for pairs, so you would have y to the 8th, and then you also can take the square root of x to the 4th, and you would have x squared. Right there, we can write it as a fraction, so that means this is rational. Now, as a quick review, rationals can be written as a ratio, also called a fraction. By definition, irrational terms cannot be written as a ratio or a fraction. Irrational terms include repeating decimals, they go on forever, non-terminating decimals, and the famous pi. And the big difference between repeating decimals and non-terminating decimals is that repeating decimals have the same pattern. So it could be 0.616161 and it goes on forever. And non-terminating decimals just have a bunch of numbers that never stop. To be considered rational, an irrational term cannot stay as a denominator. So if you can't get rid of that weird non-terminating repeating decimal or famous pi, if all those are sitting as denominator, you can't make it rational. It's not a rational number, it's considered an irrational term. And that's it for our lesson on radicals, rational and irrational algebraic terms.